Welcome and good morning to our presentation for aircraft structures. I'm Rob Bennett. I'll be doing my section, the introduction, for the design, fabrication and testing of a scaled down glider wing. I'll be followed by Andrea, Niall and Theo throughout the rest of the presentation. I'll start with the task specification. We were given this from the assignment brief. It's basically to design and fabricate a scaled down glider wing using a set of specifications predetermined. Hopefully they will be on the screen. The wing design needs to provide the maximum stiffness against bending using the minimum weight. For the fabrication we were given two pieces of balsa wood which were 102mm wide by 910mm long. They were meant to be 4mm thick, but they actually ended up being 3.2mm thick. The first thing we did as a group was to do some research into gliders, the design and the construction of them. From the research it was clear that they need to be very aerodynamically efficient, they need to be very light, and they also need to be very strong to deal with the aerodynamic pressures that are exerted on them. One book I found very useful for the research was The Glider by Stelio Frati. Lots of relevant information. With the basic glider research done, we looked at the wing structure, and we found, if you can see the picture on the screen now, that there's a main load-bearing spar that goes through the wing, and then there's smaller spars fore and aft that are they're not load-bearing as such, but they're there for the support of the ribs, and they offer support for when the wing is skinned, as it were. From the research, we saw that it had to be very light, but keep that strength. So, if you can see our design, that's what we've gone for. During our first meeting, we allocated tasks to each member of the group for the report and the presentation. I was given introduction, Andrea was given design, Niall was given fabrication, and Theo was given testing. Although these were allocated to each individual person, not one part was completed solely by one person. The whole team had input into each section. Hopefully on the screen you will see an example of one of our meetings where we talked about the design, we talked about what we needed to work out, we talked about what kind of beam we were going to use, and that continued out through the whole report and presentation. Okay, I'm going to move on to the glider wing specifications for our glider wing. The first thing we did was to look for a suitable aerofoil to meet the specifications in the assignment brief. After looking at data from gliders that are currently flying, we found that the IAR IS-28B2 glider flies within that spec. We confirmed that with the EASA type certificate datasheet for that aircraft. And the aerofoil that we've picked from the aircraft is the FX61-163, which hopefully you can see on the screen. For the assignment, it was stated that the chord length for the wing should remain constant throughout, so we don't have to worry about any tapering, but for most gliders that there would be a tape or something to get the best efficiency possible and reduce drag. So the next thing we had to do was work out the dimensions for our wing. We started with the balsa we were given. It was 910mm in length, roughly. We had to take 100mm off of that for clamping and testing. That couldn't be used for the wing. So it left us with roughly 800mm for our wingspan. We used the full 800mm for our wingspan, and using the aspect ratio given to us in the assignment brief, we came up with the chord length of 94.1mm. So that gave us the dimension of our wing. Using the dimensions of the wing, we were able to work out the wing loading, and then from the wing loading we were able to work out the load applied to the wing, scaled down. With that we can move on to design and testing. Later on Theo will show you how our wing performed during testing, but now I will hand over to Andrea, who will use the research, use the dimensions we've calculated and the scaling to design our wing. Thank you very much.